Okay. It looks like it's 2 p.m. Eastern, so we're going to go ahead and get started. But before we do, I just want to say welcome and thank you all so much for joining us today. We're really excited to have you here. My name is Kayla Ripple, and I'm a senior associate with the Lenfest Ocean Program. So for those of you who may not know us, the Lenfest Ocean Program is a grant-making program. We fund research projects and expert working groups to address priority science needs that are facing ocean and coastal decision makers. You can learn more by visiting our website at lenfestocean.org. And while you're there, you can also sign up for our newsletter. You can also follow us on Facebook and at Lenfest Ocean on Twitter. In fact, we'll be live tweeting this event today. So if you'd like to, you can follow along or interact with us there using the hashtag LOPwebinar. Joining us today are several members of an expert working group that's assessing marine mammal bycatch risk in Chilean fisheries. The project PIs include Maritza Sepúlveda from the University of Valparaíso in Chile, Ellen Hines from San Francisco State University, and Carlos Montenegro from the Instituto de Fomento Pesquero, also in Chile. Sorry if I butchered that, Carlos. And a few of their collaborators are also joining us today, including Bethany France from San Francisco State University, Fernanda Barilari from University of Valparaíso, and Luis Cocas from Subpescateria de Pesca y Acuicultura. So for us at Lenfest, we've been really impressed with the collaborative nature of this group, especially given the challenges that are posed by the pandemic, which so far have inhibited any in-person meetings from happening. So everything you hear about today has been mostly done online, which is truly inspiring, and also a great demonstration of how research can be co-developed across managers, scientists, and decision makers to address a pressing and timely challenge. Here specifically, that challenge being marine mammal bycatch, which is no easy thing to tackle, as we all know. The project stems somewhat from a body of work that we supported with the Ocean Modeling Forum's Marine Mammal Bycatch Working Group, who has released a series of products and tools that any country can use to start or continue building on their bycatch assessment programs. We actually hosted a webinar with members of that working group a couple of weeks ago, and my colleague Emily Knight will be dropping a link to the recording in the chat if you're interested to check that out also. For this project, though, the research team is collecting existing data from multiple different angles to generate methods for assessing bycatch risk in Chile's fisheries. So I'll let the researchers get into the details because I certainly don't want to do that. There's a lot of really interesting ones. But for us at Lenfest, we really hope that this can be an example of how other countries can use the varying amounts of data they have to begin assessing bycatch risk in their own fisheries. So I'm just about to turn it over to the panelists, but before I do, I just want to go over a few webinar logistics with everyone. This event is being translated to Spanish via live captioning. So if you don't already see the captions at the bottom of your screen, there's a little button that says CC, and it's at the bottom of your toolbar. If you click that button, it should enable the closed captions. All attendees are muted to prevent any feedback or echoes during the webinar, but we do want to hear from you, and we're going to try to save some time at the end for questions. So if you do have a question, please type that into the Q&A panel. You can do this at any point during the webinar. I'll be keeping track of those, and at the end, I'll read them aloud for the panelists to answer. If you have something else that's not a question, more like a comment or a statement, you can type that into the chat box. Like I said, we'll also be sharing links to project materials in the chat box as well, so keep an eye out there for those. And finally, this event is being recorded. I'll be distributing a link to the recording next week, along with any links to the materials that we share in the chat. So please feel free to share this with anyone in your networks who may be interested. We definitely want to get the word out as far and wide as we can. And I think I've covered everything. So with that, I'm going to turn it over to Maritza to get us started. Maritza, it's all yours, and I'll go to the next slide for you.
Okay, thank you very much, Kayla. Well, good afternoon, everyone. My name is Maritza Sepúlveda from the University of Valparaíso, and I want to talk a little bit about the project background and the need for a marine mammal bycatch assessment in Chile. Next, please. Well, what are the reasons for a marine mammal bycatch assessment in Chile? First, well, in many countries, fisheries bycatch of marine mammals is really poorly monitored or regulated. In Chile, in particular, there is a critical information gap about the distribution and abundance for most marine mammals, especially cetaceans. Also, and except for sea lions, there is a lack of data on the species that are the most affected by fisheries bycatch. In this sense, although there are some reports of direct interactions between marine mammals and both industrial and artisanal fisheries, their impact on local population of marine mammals has not been further evaluated. Next, please. Well, just to provide you some general characteristics of Chile. Well, Chile has an extensive coastline. Landings during 2018 were almost 4 million tons, which you can see, which come from aquaculture, artisanal fisheries, and industrial fisheries. For our country, fisheries and aquaculture exports represent a really important economic activity. You can see in the figure in the middle that the fishing areas for pelagic, the Mercel, swordfish, and crustacean fisheries, and also you can see the big number of artisanal fishermen, the boats, industrial vessels, and also the salmon farming facilities. Along with this really huge and relevant fishing activity, and explained by the high productivity of the Chilean coast, it is possible to find more than 50 species of marine mammals. Next, please. Okay, thanks. Well, based on this background, with respect, but why is this so important for us? This is because now the import provisions rule and its effects on fisheries management in Chile. Well, aside from the urgency of the conservation issue for some species and populations of marine mammals, it is especially critical to address bycatch at this time, as US regulations require nations exporting fish and fish products to the United States to be held to the same standards as US commercial fishing operation. Countries with relevant fisheries exporting to the United States have 5 years from 2017 to document their compliance. Well, as you can see, and as I mentioned before, Chile is included in the top 20 countries with the highest volume of fish products to the US. Thus, and considering that in Chile there are significant data gaps on marine mammal distribution and also abundance and bycatch rates, for our country, it is possible that the MMPA may have socioeconomic implications. Compliance with the MMPA provisions will thus pose substantial challenge for Chile, given the short-term further implementation and the irregular level of development of monitoring and reduction of marine mammal bycatch at the time of enactment of the MMPA import provisions. Next, please. Just to show you a really big picture, in this table, I just wanted to show the list of different fisheries, as well as, and at the end, the salmon aquaculture that are now considered as export fisheries. That export fishery, that is those fisheries that with more than a remote livelihood of marine mammal bycatch. Yeah. So you can see that the list is quite extensive, which represent a really great challenge for Chile. Next, please. Well, how this project was developed. We first developed our research question in January 2020 at a series of meetings in Valparaíso at the offices of the Undersecretary of Fisheries and Aquaculture, which is responsible for fisheries policy and regulations, and the Fisheries Development Institute, which is a private partnership that carries out scientific and technological research. Here in Chile, Dr. Hines gave a presentation of the ByRA toolkit, and we started to discuss the specific issues confronting Chilean fisheries, discussing research questions that at the end could help us to fill our knowledge gaps and to identify bycatch risk in our Chilean fisheries. Next, please. Next slide. Okay, so during these interactive meetings, we confirmed that the research questions would meet the specific information needs of our policymaking partners for both MMPA Import Provisions rule compliance and also to our internal management of marine mammal bycatch. So I want to just to show 4 questions. The first one is which sites along the coast and pelagic shelf of Chile would most accurately represent the myriad geographies, fisheries, marine mammal population structure, and bycatch situation of concern to Chile policymakers and scientists? 2, how can we, by using different quality and amounts of existing data, to identify and quantify specific factors, year, and fisheries that contribute to the risk of marine mammal bycatch in specific locations, scales, and seasons along the coast of Chile? The other, please, next. A third question is, what environmental and biological criteria are most significant to create a spatial explicit geodatabase, oh my gosh, of fisheries occurrence, year type, and the species distribution models of the marine mammals that most accurately characterize bycatch risk in Chile? And finally, the fourth question is, how can we most accurately create data management tools and analysis system for the analysis of marine mammal assessment, features, observations, and government observer data in the ByRA system adapted for Chilean fisheries? Next, please. Well, Ellen will provide more details of the project, but I just want to give a panoramic view of the project. Well, our project gathered a team of experts that consult with Chilean government fisheries agencies, particularly the Undersecretary of Fisheries and Aquaculture, Subsecretaría de Pesca, and the Fisheries Development Institute, the Instituto de Fomento Pesquero, together with local and international scientists to manage, analyze existing data and generate methods for gathering new data that characterize the spatial and seasonal distribution and abundance of fishing boats, gear, and marine mammals bycatch risk. Next, please. This is just to show, it's not very big, the word, sorry for that, but this is just the list of the members of our project. As you can see, I hope that the list is very extensive and includes several national and international researchers, along with managers of Chilean government fisheries agencies. Next, please. Well, for doing that, our big team was divided into 4 divisions: the marine mammals team, the fisheries team, the oceanographic team, and the socioeconomic team. Each of this group, led by Ellen, myself, and also Carlos, meet regularly to complete the data needed and see how they can contribute to the project as a whole. And finally, this project, the ByRA results, will provide SUPESCA and IFOP with information on areas and seasons of bycatch risk for ongoing monitoring, as well as the level of risk for different fishing year at those times and locations, which cut at the end support precautionary actions, policies, and to inform carefully designing research and management. And that's it. Thank you very much.
Thanks, Maritza. Up next, I think we have Carlos.
Perfect. Can you listen me?
Yep, we can hear you.
Perfect.
Sounds good.
Well, thank you very much, Kyla. Thank you very much, Maritza, for your presentation. Well, my name is Carlos Montenegro. I am in charge of the Fishery Assessment Department at IFO, and my main areas of research are ecosystem modeling, stock assessment, bycatch, and others. And first of all, I want to thanks to Lenfes Ocean Program and the San Francisco State University for the invitation that they made us to Chile to participate in this project, in particular to the University of Valparaíso and our institution, the Fishery Development Institute, IFOP, or in Spanish, Instituto de Fomento Pesquero. Our institution is in charge of carrying out the research in fisheries and aquaculture so that the state of Chile can manage both activities. Also, I want to thank to all the audience for joining us on this webinar as we are commemorating the Marine Mammal Month. It's a very special month. Well, next, please. Well, the purpose of this presentation is to show you some key stages in order to successfully implement ByRA process. This could be in another country or a specific region, and are some key stages and steps that, in our opinion, are very important to take account on. Of course, from the point of view of the fishery science. Next, please. First of all, it's very important to identify the main species of marine mammals that are present in the zone that you are working, in our case, in the economic exclusive zone, that are of interest for the study of their possible fisheries interaction or bycatch. Next, identify the main fishery that could interact with marine mammals selected in the previous stage. Because this is very important, because probably you're going to find in another places. I'm trying to figure out if this kind of project are going to be implemented in another country, very with a lot of fisheries, for example. You are going to need to identify which are the main fisheries that could interact with marine mammals in the selected in the previous step. Next, please. This is a key step in our opinion. Identify a set of criteria that allow selecting the fisheries and species of marine mammal that are included in the project. And Maritza mentioned some things about this with some of the questions, the research question that we underline. Next, please. Also, it's very important to define the spatial and temporal scope of the fishery that you are going to include in the fishery. Because, for example, in our case, we have a lot of historic time series data, but just in the last decade or in the last 7 years, something like that, we are recording information about bycatch, sighting of marine mammal, and so on. That's why important to say, well, we are going to consider the last 2 years, we are going to consider a longer period. And of course, you need to define where you are going to put in the space you are going to define which zones are more important to study. Next, please. And the other very important issue is that you need to define the spatial and temporal resolution of the study. Because, for example, you are going to be able to analyze this in a very high resolution, spatial resolution, or very low temporal resolution. For example, you can analyze this by month, by quarter, seasons, something like that, years. You need to define these kind of things. You are going to divide the zones, are issues that we faced in this project, and we discussed it with the team. And of course, we have taken the decision about all this stage 1. Next, please. Well, like you can see, Chile is a very large country, has an extensive coastline where different types of marine mammals are found. And there are a large number of species that are fishes, giving rise to a large number of fisheries, from small-scale fisheries to, for example, large fisheries like the factory vessel that operates mainly in the extreme south of Chile. But we decide, like a project team, to divide Chile in 4 zones: north, central, south, and extreme south. Next, please. Next. Okay. In this slide, I just want to introduce you to some of the main marine mammals species that inhabit the seas of Chile. We have several kinds of whales, killer whales, dolphins. We have the Southern American fur seal, Southern sea lions, sperm whale, and other species. And this is a very important to have this complete list of marine mammals, and it's very important to know the level of conservation that each of these species has, considering the UECN criteria. Next, please. Well, for example, in particular, in the south, in the very south of Chile, we have the Mercel Fishery. The Mercel Fishery has at least 13 species of marine mammal that are present in this in its waters, of which only some of these species present some degree of interaction with the fishing fleet. Not all the species that I'm presenting here interact or have a bycatch with the fleet that operates in this area. But it's important to have an idea of which marine mammals inhabit in this area. Next, please. Here we have, in particular, for the northern zone of Chile, there is another group of species, some of which, such as the southern sea lion, are present in much of the Chilean coast. Next, please. In the central zone of Chile, we also find other species that are found in specific areas, such as Juan Fernandez fur seal, which is present in the Juan Fernandez archipelago. Next. Well, regarding the main fisheries found in Chile, we have one of the most important, the fishery of small pelagic fish, which are caught using the Bursane fishing gear. Next, please. And next, please. This fleet has like target species, jack mackerel, for example. In this case, we have anchoveta, Engraulis ringen, Araucarian herring, and Falkland sprat. Several of these species are target species of this very important fishery. I think is the main fishery in Chile. And next, we have the Mercel Fishery. Next, please. This fishery is there are several fisheries in this group of the Mercel fisheries. We have, for example, some fleets that are dedicated to catch fish and another to catch crustaceans like yellow squab lobster, red squab lobster, and we have the other fleet that is more to the south. We have the Chilean common hake, that is a very important species, and we have the southern hake, Patagonian grenadier, Patagonian toothfish, or Chilean sea bass also, and other species that are caught with different fishing gears, like the icons can be seen in this slide. Next, please. Another important, very important fishery in Chile is this is dedicated to the extraction of highly migratory pelagic species. This fishery has like targets, for example, swordfish, common dolphin fish, and also some kind of sharks, shortfin mako shark, and blue shark. And we have occasional catches of other species of sharks and tunas. That's why I include the boar beagle and yellowfin tuna, but we don't have a specific fishery dedicated to operate over these species. And next, please. We have several. Just if you can remain 1 second in the previous, just to show the several kind of vessels that you can find in this fishery, a highly migratory species. Several kind of vessels, several kind of gears, and that's what I'm showing in the right of this slide. Next, please. A second stage that is very important to be able to implement successfully a ByRA process is the data gathering. This stage has several steps. The first of all is the selection of the database to be used. Next, please. In this database, we need to select the main variables to be used in each database, because I can remember in several institutions, you can find several databases in different formats with a lot of variables, and that's why we need to select the specific database that are going to be of interest to be included in the project. It's not just to put all the database on the table. We need to select, and not just the databases, but also the main variables that you are going to analyze. Next, please. And also, we need to debug and filter the database. You know, this is a major problem in all the countries that have been doing fishery research, you need to take a long time filtering and debugging databases. Is a step that is important and very time consuming. Next, please. Well, when you have a lot of several databases, it's important to create a repository with all the databases. It's not a good idea to have in some folder in the computer of one college, one database and the other in a Google Drive and something like that. In our experience, it's important to put all together. You can use several ways to do that, but it's very important to put all in the same place, and all the team has need to be able to have access to the data, to this database. Next, please. And the other very important step in this stage is the spatial presentation of the data using, of course, a geographic information system. In our case, we use mainly QGIS. Next, please. But yeah, I'm going to share and present some examples of spatial representation of the activity of different fleets over time. For example, here, next, please. The Mercel crustacean fishery has presented a fairly homogeneous and persistent spatial distribution over time in the same fishing areas. Thank you very much. From 2015 to 2019, you can see the fleet has operated in the same places. Next. On the other hand, the jack mackerel fishery is developed mainly in the south central zone of Chile and has had some degree of progressive approach to the fishing zone from the sea to areas closer to the coast. And you can see here we have also the sets from the 2015 to 2019. Next, please. The case of highly migratory species, particularly the artisanal longline fleet, operates mainly in the northern zone of Chile and not so close to the coast. This makes it quite difficult to record data on this fleet, since the vessels are very small, less than 18 meters in total length. And the main species that this fleet operates, you can see are sharks and the other species that you can see in this slide. Next, please. Well, and last but not least, another key aspect is the multidisciplinary work team. At IFOP, we have at least 3 specific teams. The first one you can see at the right is the Porcine Pelagic Fishery that is led by Rodrigo Vega. And in the Mercer Fisheries, that is Claudio Bernal in charge of these fisheries. And with the highly migratory species, we have Patricia Zarate that is in charge of this fishery. And also we have a team, and that of course I'm part of this team, that works in all the fisheries, me and Jaime Letenier, and also Eloy Alvarado. And that's the way to do this kind of things, like Maritza mentioned, with a specific and very multidisciplinary work team we are in a very good stage of this project, going through, and I'm very sure we are going to get all our goals of this project. Next, please. Well, thank you very much to all the audience and all the other speakers. Thank you very much.
Thank you, everybody. Thank you, Carlos. That was great. So now I think we have a lot of the background about the fisheries that we're working with. This has been just an amazing project so far. And it's part of a longer term project that that we've been doing, I think, for the last 4 or 5 years now. I would like to acknowledge, next slide, please, our international and in-country collaborators who've been working amazingly on Zoom. And Maritza has introduced our colleagues and teams. Carlos has introduced the IFOP team. Luis will acknowledge the SUPESCA team. I would like to acknowledge some of our special players who really made this project happen. Jason, Kayla, Emily, and Virginia from Landfast, who have been just incredible and positive support during these crazy times. And at the bottom right, you can see on our socioeconomic team, a special advisor, Dr. Stefan Gelcic from the Pontificia Universidad Católica de Chile. So we have an amazing team. And I hope to meet with everybody in person soon. Just, you know, next slide, please. So we all know that bycatch is far from resolved and is likely growing rather than receding. And there is a shortage of rigorous, comprehensive data. It's just been going on for decades now. It's a really stubborn problem. Next slide, please. And the lack of data does not mean that management and data collection should not begin. This project hopefully is getting rid of the excuse of not enough data and is very much part of a call for local capacity strengthening. That's really what ByRA is about, is starting the conversation with people all over the world who can work together on this horrible problem. Next slide, please. So the limited availability of data needed to assess the effects of bycatch are often greatest in countries where these fisheries can be fundamental to local and national economies. We need to make better use of these existing data to develop these bycatch risk assessments, which identify, analyze, and evaluate the likelihood of a probability or of an event happening and its consequences. Next slide, please. Originally using a range of available data from 5 case studies with a varying range of available data, we developed the Bycatch Toolkit to serve as a guide for resource managers and scientists to use the best available data to inform bycatch management and population assessments. Oops, sorry, stay on that one for a little bit. ByRA has been used in Thailand, Vietnam, Peninsular and Borneo, Malaysia, India, Sri Lanka, Cambodia, Peru, and now Chile, with trainings in the Philippines and Colombia. So what we do is we take whatever data are available about the distribution of both fishing animals, calculate within our model interaction rates, and come out with both an index of data uncertainty and a consequence and exposure matrix that looks at the danger to the animals of fisheries interactions. Next slide, please. So just to give you an idea of what we're doing along this very long coast of Chile, we have identified 18 different fisheries that we've been working on over this last year. And these fisheries were identified by our Chilean scientist team. Next slide. What we use is a freely downloadable modeling framework called the Bycatch Risk Assessment, which I will refer to as ByRA, that is based on methods and application from papers on documenting our work from Greg Verutis and myself, who've written a couple of papers. And there are several more papers, including an IWC submission by Vivian Kuat and Luisa Ponampalam on their work in Malaysia. ByRA is derived from the Habitat Risk Assessment model, part of the INVEST model suite from the National Capital Project out of Stanford University. Next slide, please. So ByRA begins with data collection, which in Chile involves working closely with our partner agencies, as well as participatory mapping and fishermen surveys to gather data on animal sightings, previous bycatch, and fisheries. The next step, go ahead and click one more time, Kayla. One more time. There we go. Is creating a layer of species distribution. And for this, we collect data on the environment from sources like NASA satellites or use animal data points gathered from scientific observer data, ship owner logs, formal surveys, or interviews. And if enough data, next please, we choose a species distribution modeling technique such as MaxEnt, a presence-only model suitable for small sample sizes. If not, we talk with scientists and search the literature to create a role-based model, such as you'll see in our next presentation for the sperm whale and the sea bass fishery. Next, please. The next step of ByRA is to take the species layer and use it as input along with the stressors defined as gear-specific fishing areas. For example, one more click. Here are 6 general categories of fishing gear as an example. Next, after prepping the stressor layers to fully round out the model, ByRA uses a table for incorporating expert opinion and previous literature to rate the impact of gear to the species. Next, please. This tool calculates bycatch risk as the product of summed exposure and consequence scores. Exposure is the overlap between a species distribution and the extent of a human activity in time and space. Consequence is both in terms of sensitivity. Go ahead and click a couple more times for me. There you go. As an expert assessment of how a population will respond to and recover from an impact. In terms of resilience, consequence is based on a scientific assessment of population dynamics in the life history of the species. The collaborators for each side populate exposure and consequence tables with ratings that score each gear type separately. Go ahead and go to the next map, so 2 clicks. We also use additional spatial layers to add a level of complexity to the model, taking into account more factors that can contribute to bycatch risk by location, such as fishing intensity, created to be used as a proxy for the number of vessels in the water. Likelihood of gear species interaction is an overlay of the species distribution layer and a fishing intensity layer. Then we can add additional criteria as relevant. For example, here, the temporal overlap of soak time is a layer with ratings based on the number of hours fishing gear soaks in the water. Next slide, please. We then have our preliminary maps reviewed by our colleagues. So go ahead and click for me. And reviewed by our colleagues, which is the stage we're in on our first fisheries. Then we will rerun the model to build our final synthesis. Next slide. So in our results, we have 3 main inputs that feed our conversation with management. First, the bycatch risk maps, which you'll see some of those preliminary maps in the next presentation. We're also able to look at risk percentages by various subzones of fishing intensity by gear. And we also have our exposure and consequence risk plots, which look at the combination of the different combinations of risk for each animal by each gear and show management the relative amount of risk for each animal. Next slide, please. Our tool puts existing data into this risk assessment and scenario framework. We are continuously refining it. But what we're trying to do is to embrace the spatial temporal complexity of a given system. We aim to provide policy and decision makers with maps of priority conservation areas and inform the design and configuration of spatial protection. By organizing and synthesizing ByRA in an open source online framework, the reach of our project extends beyond the local areas used to demonstrate the toolkit. Stay tuned as we keep programming the input process and fine-tuning the toolkit, which is a project that we're doing with a group of NOAA scientists right now. Next slide, please. So these beautiful Irrawaddy dolphins in the picture, I'd like to acknowledge the various funders who've helped with the whole, helped to support and encourage our whole ByRA process. So thank you very much.
Thanks so much, Ellen. My name is Bethany, and Fernanda and I are both graduate research students on the team, and we're going to share some of our preliminary results from the risk assessment scenarios that we've been working on so far. And I may move a bit quickly to stay on time, but should be good. Next slide.
So from a total of 18 selected fisheries, how Ellen said before, all of these are developed along the coast of Chile. 2 of them were chosen to start working. One of these was the Chilean common Hake industrial troll fishery that takes place in south central Chile mainly. And the other is the Chilean bass artisanal longline fishery that takes place along the Chilean coast. Next, please. So these 2 fisheries were chosen because they are both important export resources to the United States and also have different levels of information. For example, the Chilean common Hake fishery has good information on intensity of the fishing and bycatch data, interacting with the South American sea lion. And the sea bass fishery doesn't have such complete information. It doesn't present bycatch records from the period of 2015 and to 2019. But predation by sperm whales and killer whales have been reported, and uncertain interaction with sea lions, it's important to evaluate. Next, please.
So before discussing the actual fishery cases, I want to mention data sources and uncertainty. As Ellen said, ByRA can incorporate different sources of data, and we use a simple stoplight visualization to characterize uncertainty of the different categories of data, including species distribution and fishing activity. So green indicates low uncertainty, and red would represent high uncertainty and a need for caution. And so this approach is based on the published case studies in Hines et al. And Fruities et al. 2020 that I believe there are links to in the chat. So for the initial case results we're presenting today, we're looking at the South American sea lion. We used sea lion colony or haul out census data and a distance-based estimation of distribution. So both of those data types are yellow. The abundance data is high quality, but it is land-based information that we are extrapolating from. And for the fishing effort, we're using scientific observer data for the Hake fishery with very good fleet coverage, and that also includes bycatch records. And for the Chilean sea bass, we have two sources of data. We have ship owners or captain's logs, which report trip averages, and we have scientific observer data with much lower fleet coverage. So for all of our maps of initial estimated risk, you'll see a stoplight indicating the levels of certainty for that output based on these data sources. Next. Going into the initial cases we're presenting, again, the focus animal is the South American sea lion. And as I mentioned, we worked with abundance data from censuses across several years. And we split our analysis into two seasons or time periods, the reproductive season for the sea lions in January and February, and then the rest of the year, because there's different behavior when the animals are hauled out during the breeding season. And we used a distance-based methodology to estimate distribution, essentially estimating what proportion of a colony's population, so 100%, 90%, what proportion could be present within certain distances of each haul out based on sex and age class. So from previous satellite tracking and observation studies, we know roughly how far these different sex and age classes can travel. And so we were able to then weight those estimates based on the abundance level of the haul out site. So these maps show what those distributions look like. And the reproductive season also reflects the exclusion of adult males because they remain hauled out on land and are not in the water during this season. So this distribution estimate is one of the spatial inputs or criteria that go into ByRA. So if you'll go to the next slide, looking at our first scenarios, the other input is, of course, fishing activity. So this is starting with our more data poor fishery, the artisanal Chilean sea bass, which is, as Fernanda mentioned, an artisanal longline fleet that operates along almost the entire coast in deep coastal waters. And so these are maps of fishing intensity based on the captain's logbook data. And this has, again, a really large geographic extent from the far north into the extreme south. And these fishing activity maps are a second spatial input for the ByRA tool. Next slide. So we can look at the actual initial risk map results for this case. We were looking at the risk of interaction. There are no current records of capture or bycatch of sea lions in the fishery, but there can be interaction with predation of sea lions, as well as animals being attracted to discards, which can be a source of conflict. So looking at the risk maps, there are clearly clusters in the reproductive season, but with this data set, there's a larger area of risk in the far north where there is extensive fishing activity. And I'll also note, as Ellen said, that these results are going to be refined further in collaboration with the local scientists to better identify important high-risk clusters. And I think we can go to the next slide. This is the second data set for the sea bass fishery, and this is scientific observer data with fairly low fleet coverage. And you can see that there's also a more limited geographic extent. The observer coverage is mostly between 30 and 45 degrees of latitude, and there are more obvious clusters of fishing intensity, especially along the central regions around Valparaíso. But there's a lot of agreement between the two sources of data, the logbooks and the scientific observers, which is good. And so with this spatial input of the fishing activity, we can go to the next slide. We can look at the interaction risk outputs based on that data. And of course, we see the spatial patterns carry over from the fishing data because the sea lion distribution is quite continuous along the coast here. The model is finding potential areas of interaction largely based on the fishing data. And for the non-reproductive season, we have kind of small pockets of risk in the south as well as in the central area. And there's kind of a more obvious connected cluster of risk there in the center. And so with both of these data sets for the sea bass fishery, we expect to improve and clarify these higher risk areas to identify critical regions within the fisheries with our fisheries team. Next. So I can also briefly present our more data-rich scenario, which is the Chilean common hake fishery. This is an industrial trawl fishery with good scientific observer coverage, around 57%. And this also includes bycatch incidents from the fishery as well. So these are the fishing intensity maps that are weighted by fishing effort in both the January-February season and the rest of the year. And there's a similar pattern of fishing activity in both seasons, but of course, more clear intensity in the longer season. Next. So these are the risk results for this fishery, and we do have clear areas of high risk with this in this scenario, especially in the non-breeding season for sea lions. And as you see, these risk maps have kind of a mixture of yellow and green uncertainty in that stoplight because we have higher quality fishery data, but still kind of a medium level of certainty for the sea lions. And I'll just reiterate that what Ellen said, that all of these risk maps incorporate both the spatial criteria about where the animals and fisheries are, as well as other non-spatial criteria about interaction, which are species and fishery specific and kind of further describe the population of concern. Next. And because the Hake fishery is fairly well monitored, we were able to overlay actual bycatch records of the South American sea lion over our risk maps as kind of an assessment of these initial results. And over both seasons together, we found that 91% of the recorded incidental capture of sea lions overlaps with areas of relative high risk from the ByRA model. And so this agreement between the observer data and our risk estimates is kind of a useful confirmation for these initial maps. And in addition to these risk maps, as we continue working on the cetacean species of concern, we'll also be able to look at multiple gear types and multiple species in the same area. But I will hand it back to Fernanda to mention our current work in progress regarding the sea bass fishery one more time.
Yeah, so next, thank you. So finally, we are currently working on generating maps of the distribution of sperm whales on the coast of Chile to use as an input for the ByRA analysis, how, like Bethany and Helen said before. For this, we compiled sightings data from different sources, like collaborating institutions, literature and open base like OBIS and JBIF, and carry out an exhaustive bibliographic review to determine relevant environmental variables and preferred range of these variables and the distribution of the sperm whales. So can you, next click please. So as you can see in the table at your right, these are the variables that we found like more relevant for these species, like sea surface temperature, distance to shore, depth, and distance to canyons. You can see the maps above. And we determine a range from low to high and the preference for the species. So with this information, we will generate a heuristic, rule-based model, suitability model, sorry, using the methodology proposed by Kastner et al. 2006. In order to obtain a relative environmental suitability map of this species off the coast of Chile. So thank you very much.
Okay, good evening, everyone. I want to talk from the government point of view. I would like to emphasize the contribution of this project for the management of marine mammals bycatch in Chile, and how this project will support both our internal goals and the US MMPA requirements. And to do so, I think it's quite necessary to highlight some interesting action that have taken place in our country. Well, despite having highly productive waters, next please. Yeah, despite having highly productive waters that have supported an intensive fishing activity that led Chile to become one of the world's leading fish producers, our fisheries have not been exempted from sustainability issues. And this condition motivated us to undertake a deep review of our fisheries law in 2012 and 13, with the intention of reversing this negative trend and to recover the activity, and also to perform it in accordance with the increasing demands from society and markets. And another result of this review is that the conservation and sustainable use of fishing resources and their environment were now established as the main objective of our law. And this is how the topics of discards and bycatch, for example, became a priority for us, and we finally have a regulatory framework to assess and reduce these issues. Next, please. So by law, bycatch and discards must be addressed through a gradual process that involves 3 main steps. And with specific relation with the marine mammals bycatch, we have gone through an initial phase of diagnosis that began in 2013 with the deployment of observers on board who collect all the information that allowed us for the first time to quantify the problem, identify the affected species and the causes of bycatch in different fleets. This step, this initial step, required us to generate new sampling methodologies, the elaboration of species ID manuals, training, funds, and the cooperation of the fleets, right? And then in a middle step, to solve the problem, the results were discussed with the stakeholders to evaluate possible solutions, and once agreed, mandatory reduction measures were to reduce mortalities were established, such as the use of sea lion excluders or pingers, depending on the fleet, also handling protocols and good fishing practices. And finally, it was necessary to be able to control the actual compliance with the measures at sea, for which EMS were implemented in the entire industrial fleet by 2020, and the artisanal fleet will be mandatory by 2024. Well, in addition we include the use of electronic logbooks and BMS in the system. And I should mention that the observer programs are permanent, mandatory through the entire process, so we are able to evaluate the performance of the measures and do that judgment. Next, please. So therefore, when the US MMPA became a reality in 2017, Chile was already in the middle of a process that matches in many aspects with the US requirements. And fortunately, our country had a regulatory and institutional infrastructure to properly address this challenge. And we really need to do so because, as you can see in the table, the US market is very relevant for us. However, in spite of our strengths, the MMPA standards is very strict and expose some gaps that we have that must be filled in a very short time, like the one Maritza mentioned, like the restricted information we have on distribution and abundance of cetaceans in our waters, or the lack of information on all the species that might be affected by bycatch, since monitoring coverages are very low or even absent in many artisanal fisheries as to assess bycatch. So under this scenario, it is critical to make a better use of the available data to develop risk assessment in order to identify critical research areas that require immediate action. So as you can see, this project arrived in the perfect time and probably in the perfect place to be very productive. Next, please. So this is my last slide, I guess. Well, the 3 agencies in Chile related with the management of marine mammal bycatch, either in the areas of research, policies and regulation and enforcement, recognize the utility of the project, and therefore we got involved in it, mainly because this project allows to use different resolution levels of data, which is exactly what we currently have in Chile to characterize and prioritize marine mammal bycatch risk sites. Having a more detailed information on bycatch risk areas and time, as well as risk level for different fishing gears, might be used to improve ongoing monitoring and to support the adoption of precautionary action, or even to avoid over-regulation of some fishes, which is what might be happening now, since the reduction measures that I mentioned before are being applied to entire fleets without any risk distinction. The identification of these critical areas will allow us to make a more efficient use of the always limited resources we have to cover huge fishing fleets, particularly in the artisanal ones. For example, we could use the result for adapting the observer and EMS monitoring programs designs as required for achieving specific bycatch management objectives. Plotted results can be used in spatial planning as mitigation measures such as fishing gear restrictions or closures. And this is kind of personal opinion, but one of the paramount outcomes are the maps and the communication plan that the project will provide, since it will allow us to explain in a better way the bycatch risk areas to the stakeholders. And for us who are in permanent communication with fishermen, any tool that supports this area is very, very useful. And finally, our purpose, and that's why we are a very active part of the project, is to be able to incorporate the ByRA analysis to improve bycatch reduction actions in accordance with our internal regulations that I showed, and at the same time to better comply with NOAA regulation, which, as I said at the beginning, are both motivated by a common goal, which is the marine mammal conservation. And last slide, yes, I'd like to acknowledge and thanks the project for all the support, and I'd like to recognize a team of colleagues at the Subsecretaría de Pesca who have been involved in this process, especially Jorge Guerra, who is the person in charge of the marine mammal policies, who is in the meeting today also. So thank you very much.
Excellent. Thank you so much to all of our speakers for that great presentation and in-depth analysis of everything that you've been doing. It's truly a lot of stuff, and I can't believe that you've done it all over Zoom. It's quite amazing. I do realize that we are a little bit over time, so unfortunately we don't have time for verbal question and answer, but if you do have questions that weren't answered on the webinar, I highly encourage you to reach out to the project PIs that are listed here, or anyone on the research team, as well as anyone on the Lenfest Ocean Program team. We would love to hear from you and are more than happy to answer any questions you might have. So with that, I would love to again thank our speakers and our panelists for putting together such a great presentation and walking us through their project. And I'd also like to thank everyone for attending and spending some time with us today. So thanks everyone, and enjoy the rest of your day. And that's the end of the webinar. Thank you.